friends, welcome back to our channel Hi-Fi Study for You. Today in this video we are going to discuss about class 8 mathematics topic, and that is which is the basic root of mathematics, and which is the rational numbers. So in this we are going to talk about what are rational numbers and how to we do on the basis of properties of rational number, how do we do operations on them. At the end of day we are knowing that mathematics is nothing. Mathematics is just about operations that we saw. What are the operations? Yes, you might have know about that addition, subtraction, multiplication and division are the operations, and by using that only when we conclude our data that in this mathematics, that is known as which at the whole maths. Okay, so now before wasting time, let's come with me and talk about this amazing topic. Okay, so first thing, what a rational number is. What are rational numbers? So at the end of the day, rational numbers are all kinds of numbers which we see in the maths. All kinds of numbers which can be, remember there are two laws, you can say two rules which should be followed to any number. If it follow, it is a rational number. What are they? You might have excited and you must be know. So that is, yes, the first is the number should be in the form of P by Q. The number should be in the form of P by Q, and here Q should not equal to 0. Q should not equal to 0, and that is what a rational number is. And we are knowing that P and Q both should be an integer. Yes, they are must be integers, but Q should not equal to 0. If I write 4 by 5, let's suppose a simple fraction. It is also a rational number. It is represented in P by Q, where Q denominator is not equal to 0. Here denominator is not equal to 0, so it means it is a rational number. If I say you is minus 9, is minus 9 a rational number? Yes, minus 9 is a rational number, because if any number denominator, are you seeing it clearly? 9. Okay, so any number which don't have its denominator just said to be have denominator 1, but here denominator is not equal to 0, so it is also a rational number. Now that we know what a rational number is, now let's jump into the history and all about rational numbers. Okay, so first let me tell you the mystery of the term rational. You might have heard this rational. Why it is called rational? Actually, in maths, we have different kinds of number. We play with different kinds of numbers. And the main topic called number system. In number system, we study about loads kinds of numbers. Like first, today we talk about rational number, then natural numbers, integers, whole number, prime number, composite number, even or odd number. So kinds of numbers, right? So, in this rational term, in this rational word, if you look at, then you got the term ratio. You got the term ratio. What is ratio? If I write 4:5, 4:5 you can also say. So what is it? It is a ratio, right? And it is the second problem of friction. A kind of problem of division, right? A kind of division problem in maths. That's what a rational number is. It is just originated from the ratios. Okay, ratio that we saw. And this is what a rational number is. Now first, after that we will look at the properties of rational number. properties on the basis of operations that we do in maths. Okay, so there are different kinds of number, as I told you, and as we are knowing that there are numbers like natural number and natural number. I had written n here because natural number are represented by n. If I write w, it means whole numbers. Whole numbers are represented in the form of w. And I mentioned here q. Why only q? Because I hope you are knowing rational number are represented by q. Okay. Now let's look at the properties of rational numbers. Okay, let me take the duster, please. Okay. So now, properties of rational number. So the first property which we got here is the closure property. Closure property. Closure property. Here the term indicates like close. Okay, closed under subtraction, multiplication. Okay, these kinds of terms which we see here. Now, as I hope you are knowing that different kinds of numbers like integers. What are integers? A big question for you. What are integers? Yes, I hear that some of you are saying integers are all kinds of numbers, including the negatives, all the negative numbers, all the positive numbers, including the zero. Okay, which is called the closure, or which is called this integers, and in this we also talk about the closure property. And so in this closure property we are knowing that one application that we saw, the division in any kind of number will not be closed. In any kind of property also, in any kind of number, it will not close. Okay, we will talk about it later. Don't scare. So in closure property, the first number which we got here is the whole number. Let's talk about whole numbers first. The whole numbers. Okay, W. Now, what are the whole numbers? Starting from 0 to infinity. 0 to infinity, all numbers are whole numbers. So let's talk about first operation is addition. First operation is addition. So if I add two numbers, what closure property tells us actually? It actually tells us if you are adding two numbers. Let's suppose a plus b. The answer, the result you got should be belongs to the cast, or the, you can say, the class of that number. If you are adding integers, the answer should be in integers. If you are adding rational numbers, answer should be rational numbers. In rational numbers, in the form of rational numbers. So this is what a closure property tells us. So for addition, let's take two numbers for the proof. Okay, so I am taking 4 plus 3. Okay, so 4 plus 3. So this number, these both are whole numbers. If you add them up, you got 7, which is also a whole number. That satisfies, yes. Whole numbers are closed. Whole numbers are closed under addition of the closure property. Let's take about the subtraction. Is they are also closed in the subtraction? Let's check. So if, let's take the same example. If I do, but as we are knowing that when we do these kinds of questions, that sometimes the answer will be similar, but sometimes they look at some different properties, right? So we are knowing that whole numbers are not closed under this subtraction. Even integers and rational numbers are closed under addition, subtraction and multiplication, but not for the division. So here whole numbers, let's write all the numbers, integers and rational numbers. Okay, integers are closed under addition. Yes, integers are closed under addition. And then for the subtraction, as we saw, whole numbers will not closed. Whole numbers will not closed. And for integers, if we saw for the proof, so here integers will be not closed under the subtraction. Okay, so this is what it will close. Rational numbers as a kind of similar number to integers. How similar? If you write any integer, let's suppose if you write -5, which is a integer, slowly, which is an integer, but you can change it into a rational number. Even this form is also a rational number. If I just do this, it comes to the form of rational numbers. So here similar, you can remember this by relating integers and rational numbers, they are closed. Okay, when we talk about multiplication, multiply, then here this whole numbers are closed. If we just take the same example, 4 into 3, we got 12, which is a whole number. Let me write 4 into 3. So it is, yes, they are closed. Then after for integers, if we look, yes, for integers also they are closed. In fact, the positive ones you can also relate here 12, which is, yes, again a proof to be yes. Then after for rational numbers, should we take an example? Let's take, that will increase our knowledge, and these concepts are actually very important in maths to remember and solve your exercise in better way. Let's take 4 by 3 multiplied by 2 by 4. Okay, for solving this, what you always do? Just multiply all up number and down number. You are knowing in division format, the above number is numerator and the down is denominator. So here you got 8, then you got 12. Okay, so it is in the form of rational number, so they are closed. Right? For division, we are knowing that they are not closed. And if you check whether, then you got, then they are not closed. Okay, so these are how we'll look at. Okay, now if you just do for division, the same example, then you got, no, define, you got 4 by 3, which is a rational number, not a whole number. So it will be definitely not closed. So this, now the closure property is completed, and just for recap, closure property is the same format which tell us about if you add or if you do any operation between two numbers, the answer, the result you got should be belong to that number, right? Okay, next, and try for the second property, which is the commutative property. Okay, which is the commutative property. Commutative property. In this commutative property, the format of the, you can say the type of formula which we use here is, you can add numbers in any order. A plus B should be equal to B plus A. Let's try, let's prove, is they are equal or not. Let's try for first operation, addition, is they are or not. And so for whole numbers, if you look, then if you just say 4 plus 5, which is 9, is equals to 5 plus 4. 9 is equals to 9. Now I got, yes, they are equal, no difference in both. So it means addition properties satisfy according to whole numbers, they are commutative. Means here, the order in which we are doing operation doesn't matter. But if you go in the other format, in the other platform of subtraction, the order always matters. The order will always matters. Let's change the sign and see if we can do. Let's see the result is same or not. Let's try for this. Sorry, here. Okay, let's try for this. I had changed Now if you do 4 minus 5, 4 subtracted by 5, you got minus 1. And if you do once time equal, okay. Now when you do this, you got 1. Look at the difference. They are not equal. They are not equal means subtraction doesn't satisfy. Subtraction is not commutative under this. Okay, they are not commutative. And for rational numbers and integers, if we do, and then also we will get they are not. Okay, and division, we are knowing that they are not close. So as a recap, we are knowing that here we have 3 kinds of numbers, and rational numbers are closed in this commutative for addition and multiplication, not for the subtraction and division. Okay, now let's come to the next property. Now the next property is associativity. It is actually very interesting and very unique and most important. I rather so. Associativity. Associativity. This property of associativity, what it tell actually? Associativity tells us then you can put any kind. There are 3 numbers. You can put any 2 numbers in the brackets and 1 left out. This what it tells. If I look a plus in the bracket b plus c, it says, and this should be equal to, in bracket a plus b out c. Easy, right? Means you can put, there are 3 numbers, you can put 2 out of them at inside the bracket, 1 at the outward. This is what the associativity property tells us. Let's satisfy if we can do some important on the basis of kinds of number. So for whole numbers, if you look at, okay, so for whole numbers, if you look at 4 plus 5 plus 3, let's suppose. Let's see if it is equal to 4 plus 5 plus 3. If you do that, first you have, it is easy when you solve the bracket one first. If you solve the bracket one first, you got 8, and when you add 8 from that, you got 12. You got 12. Okay, when you solve the bracket, you got 9. When you add 9 to 3, you got 12. 12 is equals to 12. Yes, I am right. Addition property satisfy that according to the whole numbers, we are perfect. And for integers also, you can see they are also integers, right? So for integers also, this addition property, this property of addition satisfy the rule. For subtraction, if we look at, they will not satisfy the rule, and they will not satisfy. Let's check if we can do it. Okay, then if I do that, so they will not satisfy even the rule. If it have the minus sign, all them up, get rid of plus, then I got here 2, but here minus 2, which is don't satisfy, not equal. And for multiplication, we are knowing it satisfy the rule. Let's change the sign and see if we can do it. See if we can do it. Then, okay. So when you solve this, you have to write this, then 15, then equals to 20 into 3. When you do that, you got 60. Then when you do that, you got 60. It means 60 equals to 60. Multiplication is satisfied. Okay, and for division property, if you look, then for division it will be not satisfy the rule. For rational numbers also. Then at last, these are the whole properties, and you might have heard about distributive property. Distributive property is actually kind of similar to the associative property that we saw here. So there is not out to go in distributive property, and we are knowing as a recap. This all kinds of number will satisfy its rule for addition and multiplication always, but in closure property, subtraction is also involved only for integers and rational number. This whole line satisfies the whole properties. So this is about the rational numbers and this property. Okay, so time is going on. Now let's try for next thing which we got in rational number is plotting of number. Fastly let's do that. Plotting numbers is we can plot numbers, right? So let's plot. If we try for 8 by 4, let's suppose. Now it is like a like fraction 8 by 5. Okay, so let's plot this number on the number line, on this number line. So first you have to convert it to a mixed fraction. For converting it, you have to do like this, 4, then you got like this, and the remainder which you got goes the up, from which you are dividing goes the down, and your answer, the quotient, goes here. This is the mixed fraction which you will got. So it will be, where it will be lying? It will be lying at this number line which starts from the 1, 2. Okay, and then the above point tells about how much jumps we should take from that. So 1, 2 and 3 to this, and then we go 3 by 5. Okay, and 1 3 by 5 which actually indicates 8 by 5. This is how we plot numbers. You can practice more and more and revise these concepts forever. This is about the rational numbers. We also studied about multiplicative inverse, additive inverse. Okay, so multiplicative inverse is actually means you having two numbers. When you multiply them, result should be 1. Okay, so if I do just take the same example 8 by 5. What is the multiplicative inverse? Just the reciprocal, means oppose that number. It goes up, it goes down, denominator to numerator, numerator to denominator. So 5 by 8. And additive inverse, when you add two numbers, the result should be 0. And so for that you have to do like this. If you have 8 by 5, then additive inverse be minus 8 by 5. You can write minus 8 by 5 like that, or 8 by minus 5. All means the same, which is the additive inverse, means opposite sign. If you have positive, the additive inverse will be in negative. If you have negative, the additive inverse in positive. This is about the rational numbers. Hope you enjoyed it well and practice more and more for all your satisfaction and clear your doubts again and again. So thank you for watching the video. Bye.